All right, projectile and nonlinear motion, part 2. So, part 2, and this is 5.4 through 5.6. Okay, we already did all this, so I'm fast forwarding. Okay, now, why these components are important. Okay, a projectile is something that moves through air or space, acted on only by gravity. Okay, so what's going to come up probably every time is, well, what if I shoot a gun? So if I drop a bullet and I shoot a bullet, what's going to happen? Okay, so here's my bullet. Okay, someone Googled it for me. It goes approximately 400 meters per second. Okay, great. So if this is considered 100 meters, this distance here, or from center here, and then here's another 100, and here's another 100, and here's another 100. Okay, 400 meters in 1 second, this is where the bullet is going to be, right? Swell. What I want you to realize is at the same time gravity is affecting it, okay? Gravity is pulling down on it. So if you did the guided reading, like I asked, 5-1, what you're going to notice is it's only going to take, in that same 1 second, this bullet is going to go approximately 5 meters. That's the distance. So that's not even accurate, 5 meters. If I'm trying to make this accurate to the spacing, this is approximately 5 meters. Okay? So it's here and there. Now if you think about it, if you were shooting a gun, so if you are standing and shooting a gun, whether you're hunting or I don't want to know, any other, you're skeet shooting, you're out shooting at a target, whatever, you're at a range. Well, one, if you're at a range, a lot of times you're laying down. Keep that in mind. But even if you're standing, shooting this gun, right? You're standing. That's an inaccurate person. You're standing, shooting the gun. Your distance from ground to arm is probably about 1.5 meters if you're tall. Okay? So this is where the gun is. You have your gun ready, you're shooting. That height is about 1.5 meters. So it's going, in 1 second, it's falling 5 meters. So this bullet is going to hit the ground like here. Okay? So, now, proportionally, that's still 50 meters or greater. I mean, it's still huge. It's still great distance that it traveled horizontally. But you still always have to realize that in 1 second, the bullet is still going to go in 1 second, this bullet is still going to drop from your hand or from the cannon of the gun, from the barrel of the gun, to the ground, which is 1.5 meters, in less than a second. Okay? So just keep that in mind. So if you ever go to a shooting range, think about the distance you are from the target. Think about where the target is located. Okay. So in any situation, the vertical or the horizontal speed, as long as there's no air acting on it, is going to be consistent. So your length might go very far, but vertically, 5 meters is what it's going to drop every time in 1 second. Okay. Here are the different types of projectiles. So depending on the angle in which you throw it, it will determine where it falls. If you throw directly up, it should come directly down to you. Okay. So projectiles near the surface of the earth follow a curved path. You drew this, all right? You drew this in 5.1 guided reading, or no, concept development. You drew this exact picture. Remember, this is 5 meters, this is 20 meters, this is 45 meters, this is 80 meters, or however, or you might want to move those down. But that's the speed at which it's falling, or that's the distance at which it's falling. Okay, the horizontal component, we addressed all of these. So this is just going into greater detail. Horizontal component. When no horizontal force acts on it, it has a constant velocity. So once your hand releases it, there is nothing pushing on this ball. It has a constant velocity. That means we're pretending like friction and air resistance doesn't exist. Okay, the vertical component, we calculate that by d equals 1/2 gt squared. Someone pointed out that's the same as d is equal to 5t squared. Remember, 1/2 gravity is 5. So that'll give you the distance. So if this is free falling, at 1 second, this is 5 meters. At 2 seconds, it's 20 meters. 3 seconds, 45 meters. Right? This should be starting to make sense based on what we were talking about free fall wise. Okay. Gravity accelerates an object downwards, but it cannot affect its horizontal motion. That is just its horizontal velocity. So here we go. Shoots off of a cannon. So if you notice, is spacing, the distance between each red dot, right to left, or I guess left to right, is the same. But the distance between the dots up and down is different because that's gravity. Notice the little arrow going up and down constantly changes, but the arrow going to the right never changes. So watch that. Arrow stays the same. This is horizontal, stays the same, stays the same. Okay, let's talk vertical. Vertical, shorter, 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 nothing, longer, 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 longer. That's the action of gravity. Okay. Oh, notice we also have these. It's not going to let me write on this GIF, but it has the velocity of x, so 60 meters. Notice it's constant, and the velocity of the y component. It's changing by 10 meters a second every second. Okay. What do you notice? What is the acceleration? So this is constant. This is constant acceleration. Okay. So really important. Horizontal is completely independent of vertical. So completely, they don't interact with each other at all. Gravity does not affect how far you throw a ball. That's air pressure. That's air like resistance. Okay? So when you throw a ball, the harder you throw it, the farther distance it will go. But in 1 second, it will still drop 5 meters. Okay? Here you go. We've done this. Ball is in free fall, moves at a constant speed horizontally. Look at the grid lines. Okay. Projectile motion, simultaneously horizontal and vertical motions under the influence of gravity. I love this definition. Please write it. Okay, so we're dealing with projectile motion. This is how it would be drawn. What type of shape is that? That's a parabola. A parabola. It's a parabolic motion. So when it's accelerating vertical but maintaining constant horizontal velocity. Gravity. How does gravity affect you? Gravity is always pulling down. So for this bowling ball, that is a horizontal. It keeps it, the reason why it stays on the lane is because of gravity. But the reason it rolls forward to the pins is because of your velocity, your horizontal velocity. There's no sideways movement to gravity. Shoot a dart, drop a dart. Same situation I just drew with the bullet. Okay? In 1 second, it will fall in 5 meters to the so if the surface is less than 5 meters away, it's going to hit the ground faster. Okay? They will both hit the ground at the same time. Okay? Doesn't matter how hard you throw it. It might be way far away. Maybe you chuck that thing clear down the hall, but it's still going to hit the ground at the same time because once it relieves your hand, in 1 second it's going to drop from 0 position to the 5 meter position, no matter where it is in horizontal space. Gravity does not take a holiday on moving objects. Okay. Upwardly launched. Okay. This depends on the angle. The greater the launch angle, the higher the projectile will go. Okay. Upwardly launched. So if there were no gravity, it would keep going again. So, and the distance between the location of where it should have been and where it is. So this is, if you launch it upwards at this direction, the distance between where the original position where it should be and where it is 5. The distance between where it should be and where it actually is in space is 20. Same thing here. The distance between where it should be and where it actually is 45 meters. Okay? So we still are going to apply, like, because you're thinking about the distance fallen. Distance is 1/2 gravity times time squared. It's the same as free fall, it's just stretched out a little bit. So technically it's falling from original position. That won't necessarily give this height. That will not be acceptable for this height, because obviously at 3 seconds, that's not 45 meters off the ground. It's 45 meters from the position it should have been if it were. So again, this is where you do this into the different components. This is your resultant, and from your resultant position, it fell that many places, okay? Suppose you were flying in a plane. Okay, so we're not going to do a lot of math necessarily connecting to this. Okay, check question. Try this. If you're flying in a plane, the flying plane has a horizontal pace of 100 meters a second. Trace the path you would create in 3 seconds. So here, at 100 meters, you would be 5 meters down, right? This is 5 meters. At 2 seconds, you would be 200 meters away, but now you would be 20. The distance between that and the plane would be 20 meters. At 3 seconds, you would be way over here, okay? You would be 45 meters, okay? So, trace the path. You are like that. That's a terrible path. Sorry. Okay, try this. So you're frustrated with physics. So these should all be in your notes, please. Draw the path. How far it will... Okay, do the math now. Okay. So just so you know, when we launch stuff, when we go out on the field to do our projectiles, if you launch at a 75-degree angle, it should land at the same place as the 15-degree angle. They're complementary. 60 and 30 will land at the same place. 45 will go the greatest distance. Okay? That's information to know. All projectiles have the same initial speeds but different launch angles. Okay? There you go. Anything that adds up to 90. So, I kind of answered this. I don't know. I'll post the animation separately. I don't know if we will have enough time for it to load. Next, we're going to do a project. It's not loading the way I want it to. I'm not going to play with it. We're going to do a PhET simulation that's going to go through this next class. Okay, here's your conclusion. I'm not going to read it. You can, because my time's up. Hope this helped. That's the end. Okay, we'll do the test your knowledge in another one.